today is the first of our Solar Decathlon studios. A Solar Decathlon studio is intended to be an intensive study on a specialty topic. It's designed to challenge students to dive deeper into one topic that provides more inspiration and information to potentially support their projects. So what we're doing today, if you want to switch the slide, Michael. Our topic for today is industrialized construction. And I want to do a little level setting here as we'll go ahead and what our definition of industrialized construction is applied industrial product production methods for the manufacturing industry to traditional building construction systems. The idea here is that we've been building the same basic methods for 200 years, and we're looking to modernize a little bit. Examples of industrialized construction include off-site construction, they include prefabrication and modernization. If you want more information, here's the website, and you'll find frequently asked questions, you'll find some beginners basics, and also some advanced topics. So let me introduce our esteemed panel today. I'm going to start with Bryce LeConte. Bryce is a lifelong entrepreneur with a passion for building socially active companies. He's the founder of iUnit, which is a real estate development technology company focused on building energy efficient, smart modular communities. iUnit is proud to have built Denver's first sustainable, attainable modular apartment complex and has several other communities in the work, including an off-grid staff housing. Next is Dr. Joe Lewis, who teaches undergrad and graduate classes in operation, analysis, equipment usage, and the use of emerging technologies at Oregon State University. His research focuses on developing simulation, visualization, and automation methods for use in the construction industry. Over the last 3 years, he's been applying these techniques to analyze modular construction factories with a goal of identifying opportunities for improving productivity and reducing bottlenecks. Next, as the VP of Design and Engineering for the Volumetric Building Companies, VBC, Sarah Ann Logan has led her first-in-class integrated full-service architecture, interiors, and production engineering multidisciplinary company to become the premier innovative design firm for modular construction. One of her most valuable skills is her ability to craft buildings from a form and function perspective while simultaneously understanding the implications from a manufacturing and construction perspective. And last but not least, Shanti Ples is a senior researcher at the National Renewable Energy Lab, NREL. In his 23 years at NREL, he has focused on applied research and design processes for commercial building energy efficiency and building integrated renewable energy. 4 years ago, Shanti helped establish NREL's Industrialized Construction Innovation Team, focused on modernizing construction approaches to lowering the cost and increasing market adoption of affordable and decarbonized buildings. Thanks everyone for joining. So I think what I want to start out with for this esteemed panel is we had given a general definition of what industrialized construction is. I'd like to hear from you. What is industrialized construction according to you? I welcome anyone to speak up. Oh, everybody's muted.
Well, I can jump in.
There we go.
I can jump in. The way we look at it is it's anything from a volumetric modular all built unit in a factory to also a panelized unit that could come flat packed. So it's really the range of building a house, a building, offsite in different ways.
Would anyone else like to add to that definition of industrialized construction?
Yeah, maybe I can just jump in here. I'd just like to contrast it with traditional conventional construction. So if you just think about conventional construction, right, it's a unique industry itself with unique challenges. You're exposed to the elements, your materials are exposed to the elements. Your work site is constantly changing if you're working in this industry. not just a location from project to project, but your literal work site is changing and evolving around you. So all this leads to so many inefficiencies, and there's a huge lack of standardization of processes. And I think industrial construction really tries to alleviate some of these problems with the construction industry, right? As Bryce mentioned, with the prefab and offsite and modularization, we can really start to get some standardization in our processes, and that can really help with quality, safety, cost, and time issues that we see in construction.
Sarah, how would you say that industrialized construction differs from traditional construction design?
Everyone was talking about process. The process is just simply different. Traditional kind of architecture and design and construction has, as you walk through the phases of the project, schematic design, design development, construction documents, and then as-built, you're getting progressively more and more information added to documentation. And for industrialized construction, it's really completely turns that on its head. You often have to have all of that documentation, modeling, three-dimensional or not, upfront. So it really is, it requires the team to be established earlier. It requires decisions to be made faster, and it requires that all of the documentation be done really a lot sooner than you would in a traditional environment.
Bryce, can you add on to that about how when you're pulling together a project, what additional considerations are there when you're dealing with industrialized construction?
Yeah, everything Sarah mentioned, and then for us as a developer, who early on was looking to build these sort of communities, it was really a challenge to find a team that was willing to work on modular, because for the most part in the industry, the GC and the the GC and architectural community aren't really aware of modular and aren't really pushing it. So it's definitely a challenge. And a company like VBC that Sarah works with, or helping to fix that and give the development community kind of a turnkey solution. Because right now, as a developer, great, you've got factories that can build you the box, but then you need to put all those missing pieces together. And so for us, obviously, we learned a lot doing the first one, and we're able to take on a lot more than we did initially. But it's really difficult for the modular industry to move forward without having a turnkey solution for the development community to use modular.
So how, Shanti, I'll kind of throw this one on you, is like, how can we help with that? What is the research that is being done in this space?
Yeah, I think the way I like to think about it is we're moving from project by project design and construction processes to a product that has to be thought about upfront in normal product design, product development efforts, right? And so that's where manufacturing concepts come in, where we can do things like modeling of product development, product manufacturing. Every manufactured product has an industrialized process model behind it to understand material flows, understand manufacturing constraints. And so we're trying to bring those that expertise from other industries that have really well built up processes for understanding how to build a product to construction. And so at the same time at NREL here, we're really focused on how to take advantage of that process to get more energy efficiency, more renewable energy, more decarbonized materials embedded as part of that product, so that as this industry starts to evolve, we have decarbonization and affordable solutions kind of built in from the beginning.
Sarah, I mean, Shanti talked a little bit about like how the research that we're doing related to sustainable building practices and energy efficiency. Can you talk about how you're integrating that in your designs?
Yes. So one of the really interesting things that comes from our kind of vertical integration and also us building volumetrically is that we really understand what goes into the products and projects that we do. So, and what I mean by that is we have a unique ability to leverage certain pieces against each other. For instance, we understand that any improvement in insulation that we make affects lots of things, not just your indoor air quality, et cetera, but like potentially the sizing of your HVAC unit. So you can push and toggle various levers to not only increase sustainability in general, but to improve the overall the overall built environment. And one specific thing for us is that we are spending a lot of time in researching wood products. So bamboo is going to be really critical in our next couple of years. So not only as a structural material, but potentially also as a finished material that can withstand fire as well. So kind of learning from the heavy timber CLT world and bringing that into more of a stick frame world. So that's something that we're investing a good amount of time and funds into doing. But in doing that, we're not looking at it. We're looking at it because there's all these sustainability benefits for incorporating bamboo, but we're also looking at it as what other products can we take out of the landfill that this bamboo will replace, not just structurally, not just because it's a great material, but also like leveraging that to take other kind of caustic materials out of play, like drywall, like fire retardant treatment, that kind of thing. So what is really, for me, really exciting is that knowledge of the overall product. For us, the entire module is the product. So knowing that overall product helps us understand which levers to push and pull.
So I'm really excited. Again, this is with the Solar Decathlon program. And so the idea is to inspire the students in the next generation. Dr. Joe, I'd like to hear from you a little bit about what is it that the students are asking for, and how, what is it more could we do to inspire them with the use of these new materials and methods?
Yeah, thanks, Stacey. So I think, what I've been seeing, at least over the past 5 to 10 years, is that students are becoming increasingly aware of, these global issues that I was not aware of in college. So it's like things like climate change, urbanization, the housing affordability crisis, and all of these things. So I feel like students these days are very conscious and very aware, and they're very motivated to do something about these things. And then combine that with, you see these really cool videos of modular construction being shared on social media, and this just seems like if they had to redesign this industry from the ground up, this just seems like what they would do. So they're very motivated to learn these things, and I think there's a little bit of a supply problem in terms of educational content for students, especially at the college level. We're seeing that change a little bit. So you're starting to see some graduate level courses, and I think you're starting to see some specialization being offered at some colleges. But I think what we can do is really start to develop these courses and integrate that into the curriculum, both for architectural and for construction and civil engineering students. So there's a lot of research going on, and it's great that students have an opportunity to work on these things. Like we have some projects here with CLT, as Sarah was saying. How can we integrate mass timber into modular construction? And so when students start to work with these things, I think that's a path that they can take. And, it's just getting their hands on these types of projects.
So I have a general, go ahead.
Oh, sorry, Stacey, you mind if I jump in there a little bit? I think one thing on I'm happy to, go unprompted a little bit here, but one thing I have seen is the idea that where we all do energy modeling in Solar Decathlon projects, right, to really understand how our project is going to perform. And so we spend a lot of time thinking about the most cost-effective way to get to, say, net zero energy, or an embodied carbon calculation for CLT versus bamboo versus steel, right? And we're trying to make use our tools to make these decisions. And oftentimes, industry does that project by project. You're going after a LEED certification or a passive house certification for an individual project. One thing that's I think is definitely different in modular and offsite is a lot of that work has to be done on your standardized product that you're manufacturing as part of your process rather than a project. And so what we've seen is those tools and that analysis having to be moved up front in the project design process, even kind of the pre-development process, right, Bryce? I mean, Bryce is always asking me about if he designs a product like this, how much solar do we need for net zero energy? I'm like, I don't even know what your envelope looks like yet, right? And so we're having to really step really early on into projects where we just have a standardized product. And so that's one thing I think in the modular industrialized construction industry we're starting to learn, and and how this industry is definitely different than site built energy modeling or embodied carbon modeling. That's by the project. So just wanted to throw that out there as well.
You bring up a great question. Is like, are the skills needed to be successful in this industry different than those in traditional construction? I think that's a general question for the panel. What do you think additional, how do you have to think differently?
I always like to, I'm going to step in here, but I always like to kind of empower architects and engineers. I actually think that, we're problem solvers at heart. That's essentially what we're doing. Maybe some of us are more kind of artistic or creative with that problem solving than others, but I think that we're problem solvers. And I think that the educational system, at least for architecture and engineering, in my opinion, is teaching you to do that. So I don't think that there is anything different that needs to be taught in general to the training. I think it's just about specificity, right? I think it's about how to put things together in a slightly different way. So I think we have all the tools that we need as architects and engineers. We just have to change how we're thinking about putting them together. And that's what I think is really interesting. And that's why I think, the educational system, whether that be trade schools, all the way to, colleges and universities, I think that we just need to really tweak what we're doing and really just think about differences in process, think about differences in product, think about differences in even standardized methodology of like how we describe us moving through the process of design. If we can just rethink those things, I think it would be really interesting and helpful in the adoption of industrialized construction, at least in the States.
And that's the advantage, that's the advantage we've always said about industrial construction, is the advantage we have with the factories is we can use them as trade schools, and they can be environments for that to happen, where the next generation can learn early on about the process and all these different technologies that we have the advantage to integrate into these buildings at the factory floor. And that's really the advantage that we're talking about.
And also just improvements in the technology. Like, I'm pretty excited about where technology is now and the ability to integrate that into not only design, but also into construction or manufacturing. Like, robots are cool, but what I think is even cooler about robots is all the stuff that you have to do to make robots do what they do. And so that's really, to me, changing and opening up new education paths. Like, one of our factories is highly automated. The other one is not highly automated. And how do you training that workforce is very different, but less different than you may think, because everyone's only responsible for like one small piece of the component. So you're not really necessarily training carpenters to know everything about all parts of carpentry and to be able to solve any problem. You're really training them on one specific task. So I think we have really the ability to change what the workforce looks like from an accessibility perspective, from an inclusion perspective. And that's like really cool. And opening up, technology access to people who may not normally have had that access is really interesting.
Yeah, definitely in our industry, right, where access to labor, on-site labor, is one of like the biggest constraints and risks and reasons why we're paying so much extra every year, right? The construction cost inflation of why it continues to get more and more expensive is just finding folks to show up on the construction site becomes more and more of a challenge, right? And so broadening the labor pool, Sarah, as you're talking about, becomes a key way to mitigate that. And if we can do that through industrialized approaches, hopefully we can get ahead of some of the affordability challenges.
So I'm going to grab a couple questions out of the chat. There's been a question, is modular construction allowing for concepts like Six Sigma to be integrated into the construction process more fully? What do you guys think about that?
Yeah, I can just jump in here to get started. I think in modular, you have a lot more opportunity to have this loop, this improvement loop being implemented on a daily basis, as opposed to learning from projects and implementing it, in the next project, because you're faced with a whole set of new circumstances. So continuous learning and improvement is something that modular really allows for, just because it's one factory that you're in control of. That's a great question. And any small efficiency is really magnified because you're manufacturing multiple of the same unit as opposed to a single unique project. Sorry, go ahead, Shanti.
No, I was going to say that idea of higher quality and continuous improvement works really well for some of the energy efficiency strategies we always struggle with installing on site. That say like an airtight envelope, right, which is really about construction quality on site. And so if we can take advantage of that Six Sigma like process improvement and kind of continuous improvement opportunity to get a better air barrier every time you build a product, because every time you build a module, because you're looking at how to do it better each time, allows us to address some of the constraints and barriers we have, specifically around energy efficiency systems that are highly dependent on quality control.
So a particular challenge I know with modular, and this is a question from the chat also, is waterproofing between modules and how you make those connections. I think this has been an opportunity for new innovation and new materials. Would anyone like to talk to that a little bit?
Well, I know that's as developing modular is definitely the number one thing we keep an eye on when we take those nice weather tight buildings that left the factory, and we're trying to keep it that way as we're craning them and putting them together. Water penetration is definitely top of the list. So that's the way we've done it is, and every developer is different, but we really pushed to have the roof material done at the factory on the modulars. And as we're setting the building, the set team is making sure that everything's weather tight and seaming that roof as we get along. And at the end of the day, it's a weather tight building, because you have, horror stories where water has got into the building as they were setting it, and then you're chasing water everywhere. So water penetration is definitely top of the list.
I love that it appears we have a knowledgeable audience, because they're all like, we know what industrialized construction is. We want to get into the technology. That's what all the questions are about right now. So we're going to dig in a little bit here. Having some questions about like what new technologies are out there that are being, that are where this construction method is enabling adoption more than maybe traditional construction.
Well, I'm gonna speak. I can jump in and speak to the front end maybe a little bit on this. Mm-hmm. I think one of the things that for me, COVID has taught me is that because industrialized construction, you're often collaborating with people from lots of different parts of the world or nation. And you often need to, because there aren't a lot of localized kind of service providers in this industry. And what happened with COVID, specifically on technology, is that those teams were already kind of electronically tethered through programs like BIM 360 for Autodesk or Procore or any of those things. So we already were kind of a decentralized team. And so when COVID hit and other architects and teams were having to figure this stuff out, like how do we go into the cloud with our really large Revit files and really large sharing of documents and other information, we were already set up to do that. And that was really very, very interesting. And I think that that's what is kind of exciting about the industrialized construction space right now, is that you have large architects, large engineering teams that aside from the teams that worked on international projects, they were really very much localized, using their localized contractors and their localized engineering teams. And they were really working in their own silos And in this space, we can't work in the silos. So from a technology perspective, just the information sharing and documentation advances over the last 10 years have been really allowing us to adapt more quickly to this space that is actually very highly technologically driven. So that's from the front.
Stacey, oh, I'm happy to jump in on maybe some of the HVAC system technology integration we're seeing. I think when we talk about decarbonized, all electric, net zero, multifamily, we're talking about heat pump hot water heaters, and there's a centralized versus decentralized component. If we're trying to install the full system in the factory at a modular scale, we're really being forced into figuring out cost-effective ways to decentralize all of our heating, cooling, ventilation, and hot water systems. And so, and in the manufacturing world, there's this concept of chunking out major components. And so in construction, we've seen things like bathroom pods be prefabricated offsite as a major component. And if you're repeating the same bathroom 100 times in a building, you can really get ahead of the assembly process by pre-manufacturing that component. And so if we're moving towards decentralized HVAC, hot water, and things like ERVs, how can we chunk out that major component as a kind of energy exchange pod, if you will? We're starting to get closer with some of that equipment. We haven't fully integrated it all, but I think the opportunity in this industry is suggesting that when you get to a certain amount of scale, that becomes a way to pre-manufacture those kind of high value, high cost, high coordination. You have 3 trades in a little 5-foot, by 4-foot mechanical room, all fighting for space. Installing their equipment becomes a challenge. If we can pre-manufacture that, lots of ways to streamline the process there. So something I see on the new technology integration side, I'm pretty excited for.
I'd just like to jump in with one project that we have going on here at the university, which is looking at using mass timber in modular factories. And I think the thinking there is, modular really allows us to use these types of large format materials, whereas earlier your plywood sheets and all that were designed to be carried on the site by workers. With modular, because you already have these large scale equipment and cranes already installed, you can start to experiment with these larger format materials, and can also do things like, there's a question about personalization. So you can employ CNC machines and so on in modular factories, which is just a lot easier to deploy than on conventional sites. So modular, it really allows us to try these newer types of materials that we've not tried earlier.
And it allows for, sorry, one other thing is that it allows for consolidation of investment, right? So you're taking a high value kind of investment in a modular factory or a panelized factory or whatever, and you're just kind of leveraging that by adding additional investment there. Whereas I think you often pay for these kind of custom things that you want included a higher price tag when you're trying to do that on a project by project basis. So it kind of goes back to this whole project versus product mentality. Like you can have better things, you can have more things if we spend the time engineering it and designing it as a product, as opposed to adding it as a one-off on a project.
So when talking about integration of technology, so one of the things that when I say industrialized construction, it is not just offsite construction and modular. It's any time we've applied industrialization innovations to the process. An example of that that's often in this category is 3D printing. So we're having a couple questions in the chat about 3D printing. Does anyone have any experience with it or how we integrate that into the designs?
I don't, but as a developer, the issue I have with 3D printing is it only solves one small layer of the equation, and I'm still not convinced how well it does that. Because let's just say let's say 3D print the building, and we focus on apartment buildings, so that's yet to be seen how you would 3D print an apartment building. But let's just stick with a house. You 3D print the house, you still haven't solved the kitchens, the bathrooms, the electrical, the plumbing. And for us, especially for us, with our goal to build more attainable affordable housing, we need to be as efficient as we can, and volumetric modular we feel is the way for us to do it. So for us, 3D printer just doesn't do that, and I still don't quite understand where it goes and how it's competitive versus panelization or CLT or all these other things that we already have. I just don't. I'm probably missing something. I don't see it.
Bryce,
But
you
I
haven't tried to
guess
build on the moon yet.
Probably, there you go, on the moon. That's probably where it's going to work.
Sorry,
But-
Sarah,
but
go
I-
ahead.
But I guess like one of the things, I don't have a ton of experience with 3D printing, but at least, overall structures. There's a couple of companies that are really awesome at it. Mighty Buildings, I'm thinking about, based in Oakland, they're really awesome. But I think what you have to think about when you're taking something that maybe isn't an all-in-one solution is how do you modularize other pieces of it, right? So kitchens and bathrooms, you're right, they can't be 3D. They're, at least right now, are not being 3D printed, right? But then do you have other collaborations where you're standardizing that product line to go into your standardized 3D printed model? I think that when you do something like 3D printing, you just have to do more other things in order to make that really a full product offering.
I just don't know. Again, this is for us with being as cost effective as we can. I don't know that helps on the cost part, and also and then the weather penetration that we talked about earlier. I mean, I can see so many ways on